For our next talk here, we have more folks from NASA's guest disk. We have Eni Awowale, who is an earth scientist, and then Lucas Sturzinger, who works as an atmospheric scientist. Thanks, guys.
All right, thank you. So today we're going to be talking about simplifying analysis of hierarchical HDF5 and NetCDF4 files with Xarray-datatree. And yes, that's a mouthful, so we're just going to go with how trees can help you. So a little bit about us. We're kind of like a ragtag team of scientists and engineers. I'm Eni, I'm an earth scientist and engineer at NASA JASDIS. I'm also a new Xarray core dev. We have Tom, who works at Seaworthy and as an Xarray core developer, and also helped, he's the original author of DataTree. And Lucas, who I work with, is an atmospheric scientist and software engineer at NASA JASDIS. Also, big thanks to Nicholas Lenson, Owen Littlejohns, Matt Savoy. Those are our colleagues at NASA, and also Stefan Hoyer, who has been part of the DataTree migration effort. I'll let Lucas take it off talking about JASDIS.
Yeah, thanks, Eni. I'm going to go ahead and talk about some old, boring stuff so that Eni can talk about the new, exciting stuff. So first of all, who are we? We're JESDISC, or the Goddard Earth Sciences Data and Information Services Center, one of the many, many NASA acronyms, and more specifically, one of the 12 NASA Distributed Active Archive Centers. So NASA has 12 centers across the country that are tasked with archiving and disseminating to the public the Earth observing data. We are one of the ones here in the circle, located at the Goddard Space Flight Center in Greenbelt, Maryland. Our data sets primarily deal with things like atmospheric composition and dynamics, global precipitation, solar radiance. You may know us from such popular data sets as the Global Precipitation Measurement constellation of satellites, MER2 reanalysis, the NLDAS, GLDAS, FLDAS Surface Model Suite, and Aqua, SNPP, and JPSS 1 and 2 atmospheric sounders. So, a lot of this work is motivated by the fact that we are moving, along with all the other DACs, our data to the cloud. Our archives are totaling a bit over 6 petabytes at this moment. And moving these data to the cloud involves creating a set of unified cloud service code that will unify all of the DAC data together for us to be able to do things like give you, the public, spatial subsets, temporal subsets, stuff like that. And so in doing that, we need a robust way to create and test that these services are actually working for our cloud-hosted data. And so what I'm going to talk to you a little bit about today is a format that most of our data is stored in, which is called HDF, or the Hierarchical Data Format. This is also here a fun graph to show. This is the current data holdings across all the NASA archives. We're at about 100 petabytes currently, and growing over the next decade or so, especially with new missions being added, about 600 petabytes. So this is a problem that is hard to get ahead of because it just keeps coming. So HDF, in case some of you aren't aware, it's a model for storing, managing, and describing data. HDF4 dates back to the 1980s. HDF5, which is probably the more well-known version, came out in the 1990s from the National Center for Supercomputing Applications at the University of Illinois. The current spec is HDF5. It's managed by the nonprofit HDF Group, and it's the storage specification for a mass majority of Earth observing data. It's also used internally by NetCDF4, which might be a bit more well-known in the climate space. That format uses HDF as a storage specification internally. This is in due large part by NASA, who back in the 1990s selected HDF out of a competition of a bunch of different data formats for use in some of the early Earth observing system satellites. So, why is this good? Well, it's much. I'm going to talk about specifically HDF5 from this point forward, and so will Eni. Benefits of this is if you know HDF4, HDF5 is actually much more simple. It allows for multidimensional data. It's self-describing, which shouldn't sound like a huge benefit, but if you were working with data in specifications that were created before the 1980s, you had to use like external tables and stuff to actually describe what the data inside is. It supports heterogeneous data. It's an open format, open source. It's supported data slicing and very much a broad support of different programming languages and toolkits. And it's efficient. It stores data in compressible binary blocks. But it's designed for on-disk storage, which makes it difficult to optimize for the cloud, which is one of the big problems we're running into. And also, which is going to be kind of the focus of the rest of the talk, it's a complex, very open-ended format, especially when NASA decided to create its own spin-off HDF EOS version, which even added more complexity. The NetCDF4 model is actually HDF, but with less features in order to try and get things a bit more pared down and consistent. But what this means is that there's a lot of different ways of structuring an HDF file. But there are two main concepts, datasets and groups. A dataset is a multi-dimensional array, a single array of data with its own attributes and metadata. And a group is a collection of datasets or groups. And a dataset or a group might belong to one group or many groups, and groups can self-reference each other, and this can all get very complicated very, very quickly. It acts very similar to like the directory system in a Unix file system. There is a root group always, and then optionally, but not always, subgroups and sub-subgroups under that, each containing various datasets. Now, the thing that really makes our lives hard is that these group and metadata structures can vary wildly between datasets, what we call quirky data, which makes building these kind of generic subsetting tools quite difficult because trying to make it making it dataset agnostic is difficult when different datasets and data providers are kind of treating these standards differently. So one of our team's primary objectives at JustDisk is to provide a subsetting service for all the different datasets, including spatial, temporal, variable subsetting services. And this is difficult, as I said, because the datasets treat groups differently. In popular tools like Xarray and NetCDF4, you have to specify the group to open, and when you have the data opened in those tools, you can only view the data in that group. So actually looping over a whole dataset means figuring out what the group structure is, and then specifying it each time you do an open dataset to try and figure that out. And so I think that's everything here. Yeah, to talk about kind of an example of this and how we've used some modern open source tooling to overcome this problem, Ennie's going to talk about Xarray-datatree.
Awesome. Thanks, Lucas. So a little bit before getting into DataTree, so this is kind of how we've dealt with subsetting groups at the JustDisk. So we basically like make a copy of the file and then like open it with NetCDF4. And we loop through like every group and subgroup for variables and dimensions, and then we can like flatten a data set. So then to flatten a data set, we copy all of the variables and move it into the root group, but we change the variable name so it contains like the full path of the group that it's in, and then we can actually delete the variable completely from its respective group, and then just like delete the group. And then, if there are subgroups, we use this like flattening function recursively. And then now we can actually do like the variable or coordinate subset since like the data set's been flattened. But then we have to preserve the group hierarchy of the original file. So we do this by creating like a new NetCDF data set with the original groups of the original data set. And then we know this from the variables that are in the root group because we appended it with like the name of the full path name of the original groups in it. So then we recreate these groups and then put the variables back in there and copy the variables back in there and change their names also back to the original names that didn't include the groups. So that was like a lot. I probably have you all looking like this, but we know this, we know it's kind of confusing, and we also know this isn't perfect, right? It's like you have a box, and you have to you open a box, right, and you unpack it, and then you reorganize everything in the box, and then you take the things you don't want, and then you get another box, and then you put everything back in. It's just like you have to unpack and package a data set. And some of the other challenges is that it's like, supporting recursive code is just kind of inherently challenging because bugs like lead to infinite loops. It's not super great for memory because we have to copy, every time we do a subset request, we actually have to make a copy of the original data set. So essentially you have two different data sets. It makes the code kind of just not great to visualize and follow, as you all can maybe attest to. It also just slows down the processing speed because all of this is done on disk. So kind of like in an ideal world, like what do we want? Like, we want a simple way to like open grouped HDF files. So something with like minimal code complexity, something relatively fast, and something that also like reduces the amount of duplication. So like we don't have to copy the data set multiple times. And like I think ultimately something that just like understands the group hierarchy without a user having to like specify it beforehand. And ideally something that's like works as simple as OpenDataTree. So a little bit about Xarray. Xarray is like a NUM-focused sponsored project, and it's also part of like the Pangeo stack. But since this is like the Earth Geoscience track, I'm sure y'all are familiar with it. But it provides ND labeled arrays, and the cool thing about that is like you can just select dimension equals time, and then you like get that dimension. And it's also like super flexible. It scales really fast with Dask. And it's also just like an in-memory representation of like a NetCDF group. So like this, next. So who here has like opened multiple Xarray dataset objects for just like one dataset? Cool. That's a good amount of people. So, and then like, you might like, before you even like open a data set, you might like open it by like doing like an NC dump or like a netcdf.dataset.groups to get all of the groups. And then after you have all the groups, you actually then open all of them, maybe like through a for loop or just like individually with like an xarray.open, and then you select the group. But sort of, the problem with this is like you're kind of treating each group like it's a separate data set, whereas like it's just one data set with multiple groups. And this is like what DataTree like kind of seeks to improve upon. So DataTree is like a hierarchical tree of Xarray data sets. So we're all familiar with this like this Xarray data set model. And we have like the variables, we have the coordinates and our dimensions, and that's just like all in the data array, and that's like packaged into a data set. But with DataTree, we have each data set, it's actually a node within the tree, and it's reflected as like a subtree. So now it enables us to be able to actually see the whole data set and open it in a way that's like that reflects the entirety of the data set without actually having to open it individually. So yeah, this is sort of just like what it would look like if you were like to open it with xarray.OpenDataTree. So here's another example. So a couple of features is that you can open a NetCDF4 file or a Xarray store containing multiple groups. So this is an example of a GESDIS data set for like atmospheric carbon, and you can see all of the different groups there with the variables and the attributes. So it's all just like nested in, and you get like the subgroups within there. The other thing is like you can also just like write out like a data set with multiple groups pretty easily. I think probably like my favorite feature is just that like it's super interactive. So you just have like an HTML wrapper of like all of the groups there. You can like click around. You can just see like what's in the data set before you do like your computations or you do your plotting. The other cool thing is that it's like it's a hierarchical tree. So it's like a parent-child relationship. So we're gonna do a Simpsons reference. So like like Abe is the data tree, and then you have Homer, and then all of the children are like Bart, Lisa, and Maggie. Sorry, Marge, it's not a family tree. So it's like it's a hierarchical tree. So like a parent can have multiple children, but a child can only have one parent. So the other cool thing I like about it is also just like you can access it like just how you'd access a file path. So it just has like a Unix file path representation. The other thing is accessing it by like attributes. So if you have like a data tree, for example, with like the OCO2 tree, you call the group, and then you can actually call like the variable after that. So that's a really nice feature. The other really cool feature, I think all of them are cool, so I'm just going to say that they're all really cool, is that you get all of like Xarray's like standard computations, and you can like map them over the entire tree. So like you just want to like get the mean for the time dimension, dt.mean, and you're able to do that. But you can also do those like custom computations. So like if you wanted to do like a custom computation over like space, mean over xy, you can do that and just use that function map over subtree. So it's really customizable, and you get all of the same computations you would with Xarray. So kind of next, circling back to like how we all like started, how this effort started, and how we're like using it at Justice. We've already been able to start using like DataTree for testing our like cloud subsetting services. And like Justice has been able to like onboard about like 86 terabytes worth of data, and that's just been within like the last 6 months. But there's going to be a lot more. We're going to eventually like onboard all of our granules, and we've been able to do that by using DataTree as a way to validate validate those data sets. And the major plan that we actually have for DataTree is to use it as like our primary tool for doing cloud subsetting. So we wouldn't have to do that like long, laborious process of like flattening and unflattening and repackaging a data set. So I think kind of circling way back, I think also all of this just like ties into like NASA's Open Science Initiative. So like NASA's committed to like the open sharing of software and data and information, and just like supporting software and tools that like, that support, or like supporting people who support software and data and tools and products for open science. And I think like that commitment is shown through like the support of like NASA engineers and scientists like myself and Owen Littlejohns and Matt Savoy as being developers of like open source software. And a little bit about how we were like kind of able to do this. So Tom prototyped DataTree while like working at Columbia a few years ago, and it's like kind of like a semi-official prototype for a while. Everyone's like we're gathering feedback from the community, and actually I learned about DataTree about a year ago at SciPy last year, and we thought it'd be a really cool thing to like integrate into like our own workflows. And other NASA ESDIS engineers also heard about DataTree and like the integration effort. So we kind of all like were like, oh, that sounds fun, let's do that. So we were able to get retasked, and for that to be like our like primary, not necessarily just primary, but like we were able to get retasked to help with the integration effort. So like primarily the work's been done with that, with SNEC NASA folks, but we got like regular supervision from Stefan and Tom. And like now we're planning on making DataTree public for the next Xarray release. So I'm gonna like end with this like slightly corny quote. So our former DAC manager would say like, you shouldn't have to download the whole Earth to do Earth science. And I really like that quote because it kind of like makes me feel good inside, but it's also like, I think it speaks to the spirit of this effort of like, we as NASA, like we can sort of like leverage the tools of the open source community and like work together, and we can like really do cool things. So yeah, thanks for listening, y'all. Also, thank everyone at Justice. Thank especially Nick, our colleagues at ESDIS and NSIDC, Owen and Matt, and also just like the whole Xarray team and like the DataTree team. Thanks, guys.
Thank you so much. Any questions from the audience?
So I know that you had mentioned that it's going to be a part of the next Xarray release, and that it's sort of moving from Xarray-datatree as a package into Xarray proper. Are there plans to include similar like backend functionality where people could, say for example, they don't have a Xarray, they don't have a NetCDF4, or a NetCDF4 with groups file? Will there be like a similar backend similar to the existing Xarray open data set?
I believe so. Yeah. I feel free to.
Yeah, we've already implemented that for NetCDF and Xarray, and you could use, because we've integrated it into Xarray's backend framework, then the infrastructure is basically there, so that if you had your own weird file type. Like grib is a good example. Like you can think of grid as a tree with some massaging. Like someone could now go and extend their grib Xarray backend to understand groups or something like that.
Mine's more of a stupid question about the history of the file formats. Was there a HDF3, 2, 1?
I don't think so.
I think it just
But I'm not actually sure. Anybody who's been around longer than me can answer that in the room? Thumbs up, thumbs down? The oldest I'm aware of is HDF4 in that group. So.
Right. The follow-up question is probably fairly predictable. NetCDF4?
There is a NetCDF3,
Okay.
but it's different.
Why not NetCDF5?
Yeah.
The question is, why don't they just start at 1? I mean,
Yeah. Importantly, NetCDF4 is the version that implemented HDF as its storage layer. And so the previous versions of NetCDF had a different storage mechanism.
Okay.
So this is kind of a way to unify a lot of the earth science data that we're working on. And every NetCDF file is an HDF file, but not every HDF file is a NetCDF file,
Yeah.
or NetCDF4, I should say.
HDF3, HDF4 were also similar.
Thank you, Ryan.
So NASA sort of committed to these file formats like in the 90s, it sounds like. If you were to reimagine, reprocessing this data with today's formats, what would you use?
I would use Kerchunk probably, but I don't know. Do you want it?
You should use Xar. Everyone should use Xar. Like Xar solves all these problems in a way that works for the cloud.
So why doesn't NASA reprocess?
So this directly relates
Money.
to this directly relates to another project I've been working on, which I would have submitted a talk to SciPy about, but I only came up with the idea after the submission deadline, which is like, I mean, it's really goes back to other work like Kerchunk that other people have done, but basically like Xar is general enough that most other file formats can be thought of as like accessible via a Xar access pattern. So there are like significant efforts at NASA to like translate their existing NetCDF files into Xar, but there's also this whole idea that you could just make Xar be a sort of universal access layer into all the legacy file formats, including NetCDF4 and HDF5, but not limited to those as well. But it's like a whole other like rabbit hole. But that's the direction I think that we should go in, basically.
I will also add that like NASA's been talking about missions that are going to be like cloud native. You can speak to that a little bit more, like the AOS mission. So there's talk about it, but we've been using like a format for like a long time, and I think there's some sort of there's a little bit of pushback in that.
Totally. Thanks.
I want to add that like community support of these libraries is really important too. So if the entire scientific community is used to HDF as an underlying storage layer, then it's really, really hard to move the needle on that. And also, we're really good at making satellites that are expected to last 5 years, last 25 years. And so we're still dealing with decisions that were made in the 1990s because the platforms are still up in the space.
Hi, I have a question related to HDF. So I recently heard in this conference, I heard about cloud optimized HDF and how it's different from native HDF. And my other question is there any cloud optimized NetCDF too?
I guess I'll take this one.
Yeah.
This is off the rails a bit from this talk, but that's a good question. So I think the thing that I see making HDF more cloud optimized is how it goes with efficient reading of it over a network, like over S3 protocol. And so the biggest thing in a nutshell to do that is to pack all of the metadata at the very front of the file so that we can grab it all at once rather than having to scan through the file. That same process can happen with NetCDF as well, because the internal file structure is very, very similar.
Thanks.
Quick question. When is this expected to be merged into the upstream Xarray?
Relatively soon. I don't want to like put a deadline. Yeah, hopefully like within the next release or so. Yeah.
The monthly releases for Xarray, right?
Bi-monthly, yeah. But bi-weekly-ish. But yeah, you can also just like test. You can use DataTree now, like
It's also in May.
yeah, like
If you want to try it, it's in
yeah.
It's just we just haven't put it in the documentation yet. So if you want to try it, you can go and upload the main branch.
Hey, thanks for the talk. How do I convince my team that this isn't just a prototype or some other extension that they have to install and this is actually good to put into production?
I mean, I don't think I don't think. I feel like it's gonna once it gets released, I think that would do a good job of convincing them.
So from the point of view, I think that's a good question. And from the point of view of like being Xarray maintainer, then it has been a prototype for almost 3 years as a separate repository, deliberately so that it could be agile and so that I could make breaking changes if I decided that something was a bad idea. What we're advertising here is kind of drawing a line under that and saying like, we're actually pretty happy with it. Like it's going into Xarray main now. It's going to have like more long-term support. We're going to make like more promises about it. So like that's supposed to be the answer to your question, is that like once it's in Xarray main, it has these promises associated with it. And the reason I was so happy that all these NASA people came along to help and added is that it also improves the longevity by reducing the bus factor on the code. So like we now have 5 people who understand how it works rather than 1 person who understands how it works.
Oh yeah, you got sure.
As I was going to say, as someone who's like also tried this out, and I mean, sort of increasing that bus factor and stuff like that, it's a lot more useful than sort of the existing tools that were in there. Yeah, like there's a lot of tools already being built around this. It's been tested with other packages, especially with like radar data, like we've been doing. So yeah, it's pretty robust.
Thanks, this is really great. Is DataTree reading in the file hierarchy, or is it reading the entire granule in like data set into memory, and is lazy loading an option if that's true?
So there are a couple things. It's opening each group. It's opening each group individually multiple times, and then it's accessing the memory, the NetCDF memory, in memory. So.
The original implementation was a naive loop, which required opening the file many times. One of the things that we've done when we moved it into main is to push that deeper into the backends system within Xarray. And so Alfonso, who's here somewhere, had this PR that literally made it like 1,000 times faster to open a NetCDF file with many nested groups compared to the naive implementation, because it actually opens all of the groups in the hierarchy. It reads all the groups in the hierarchy with only one opening of the file, basically. And because you're creating Xarray variables in the normal way, you get all the lazy loading stuff for free, basically. So, yeah.
Yeah, thank you for the talk. Congratulations on becoming an Xarray core maintainer. You guys did a great job of kind of describing the history of HDF5 and NASA, and I kind of think of NASA as having a long-term, kind of symbiotic relationship with the HDF5 group, and I wonder, do you see like a similar thing evolving for NASA's relationship with like Xarray as a library, or some of those packages that you're relying on more and more through this work?
Yeah, I think that would be, I would definitely love that. And I think there's definitely been a push for having more NASA folks in like the sort of in the open source world. So I can definitely see that.
We would love that. Like, I mean, I feel like we're in this position where like both Xarray and Xarray are having wider and wider use within large institutions and it's like, we want more, the more developer time and the more financial support we can get, the better, because at the moment it's disproportionate. Like there are other groups for other software, including HDF5, that get much more support financially than like Xarray does, even though the numbers of users don't reflect that. So that would be great.
Okay, thanks everyone for coming today.
Awesome.
Come back tomorrow morning for more great talks. And
Cool.
Thank you guys.
Thanks, y'all.